All right, so 3-1, this is basic atomic structure and the isotopes. Hopefully you have a periodic table handy. We will give you one during the test, but you need one to do quite a bit of this. All right, first up is just reviewing the subatomic particles and where they're found and how big they are and what their charge is and so forth. So protons and neutrons, they're both found in the nucleus. Protons are positive, think P and P. Neutrons are neutral. They don't have a charge, they're just a bunch of duds. So if you think about the nucleus itself, it's got protons, which are positive, and it's got a bunch of neutral duds in there that just take up space. That makes the nucleus overall positive. The electrons are zipping around in the electron cloud. We spent a whole lot of time talking about the electrons and where in the electron cloud they're probably found most of the time, but they are negative and they are unbelievably tiny, and we don't even count their mass. So when we're talking about how big or how heavy I don't know, let's go with a carbon nucleus is. We'll go with carbon-12. Carbon-12, because it's carbon, is atomic number 6, has 6 protons and 6 neutrons. If you add the 6 and the 6 together, you get the 12, you get the mass. Notice that we didn't count any of those electrons. All we counted was the particles, or were the particles inside the nucleus. The protons have a mass of 1, the neutrons have a mass of 1, add them together, you get the grand total. So the mass of carbon, one atom, is 12 AMU. And that's the most common isotope of carbon that we find. All right, this is important. Which part of the atom makes up most of the atom's volume? The volume is the majority of the space, and that's the empty electron cloud. For the most part, it's empty space. Most of the atom, most of U, is empty. The mass, however, is all scrunched up in that little itty-bitty tiny nucleus. That's where the protons and neutrons are. So if you look at this picture here, we've got the unbelievably tiny nucleus. Technically, the artist should not have drawn anything visible here, because if this is the size of the overall atom, this nucleus would be too small to be seen. But the artist wanted to show you that here's your protons and your neutrons, and they're in the nucleus, and the electrons are zipping around in the electron cloud. So the volume is around the outside here. The majority of the atom and the nucleus, the mass, is that little tiny, tiny space on the inside. Okay. All right, some other things that we need to know. Atom's atomic number is equal to the number of protons. The mass number is what we just looked at with the carbon-12. It's the protons and the neutrons in the nucleus of one particular atom. Now, the mass number and the average atomic mass are two different things. I know the word mass is in both, and probably in your head it just makes you think weight or how heavy it is, but it is not the same thing. The mass number and the average atomic mass are two different things. If we look on the periodic table, we see all of these big numbers here, 24, 25, 26, those are all the atomic numbers, the numbers on top. The numbers on the bottom, like let's look at carbon here. Carbon's 12.0, nitrogen's 14.0, those are the average atomic masses. That is not the mass number. Like I'm not going to have, let's look at potassium. I'm not going to have an atom of potassium that has a mass of 39.1. There's no atom there that when you add up the protons and neutrons, you come up with 39.1. That does not happen. They've got to be whole number counts. So the average atomic mass is different because it takes in to consideration the masses of all the isotopes and how abundant they each are. And we'll get into that in a minute. Let's focus on mass number for now, though. It says, how do you determine the number of neutrons in the nucleus? You take the protons. You take the protons and subtract them from the mass number. So if my mass number is 12 and I know it's carbon, I know I have 6 protons, then I know 12 minus 6 leaves me with 6 neutrons. If I had a different isotope, if it was carbon-14, I still have 6 protons because it's carbon. Subtract from the 14 and that leaves me with 8 neutrons. So mass number minus the atomic number. Different ways to express information. We have something called the nuclear symbol and the isotope name. The nuclear symbol is the symbol, 2 letters, 1 if there's only 1, or 2, second letters always lowercase. But the 2-letter symbol or 1, and the mass on top, atomic number on the bottom. This is the bigger number. This is the smaller number. So if I was looking at carbon 14, I would write carbon, only one letter, 14 over 6. That's my atomic number. That's my protons. This is protons plus neutrons. And this is just protons. And from that, I can figure out how many neutrons there are by just subtracting. The charge is written on the right. So if carbon has a charge, you would write it over here. Carbon doesn't really make a charge, so we're not going to write anything. But if it did have an uneven number of protons and neutrons, that's where we put it. The other way to write information is the isotope name. And I've been using that a little bit here. I said carbon 12 versus carbon 14. So if I wrote carbon 6, if I wrote the atomic number there, that wouldn't tell me anything because they'd both be carbon 6. So that's useless. It's not the atomic number, it's the mass number. It's protons and neutrons. So carbon 12 is the mass, carbon 14 is the mass. And you can write either the name or the symbol. Some people like to write out carbon 14, or you just write C14. What's the difference between isotopes of the same element? They have different number of neutrons. The neutrons is different. Protons always stays the same. In both cases, carbon has 6 protons, but it's the number of neutrons. It could be 6 neutrons, or it could be 6 or 8 neutrons for carbon 12 and carbon 14. Explain the difference between an atom and an ion. Atom is neutral. So if you see something that says atom, you automatically know that protons equals the electrons. If you see an ion, if it says, what's the charge on the ion, or this is an ion, then that means protons are not equal to electrons. This never changed. This stayed the same, but the electrons changed. Atoms can lose or gain electrons to become ions, which you should now be a pro at. Now, we got to fill out this periodic table, or fill out the table at the top of this using a periodic table. Now again, I'm going to give you a periodic table on the exam, and you'll have one for every test in the future. But you should know what to do with it. First up, the protons equals the atomic number. So if you know these two things are the same. If you know there's 8 protons, you automatically know there's 8, or the atomic number is 8. So then you just look on your periodic table and say, well, what element is that? And in that case, it's oxygen. So you write oxygen here. Now, the mass number is protons plus neutrons. So there's 8 protons and 9 neutrons. So 8 plus 9 is 17. Now, when you write the nuclear symbol, it's the symbol and it's the mass on top, 17 over 8, the atomic number or number of protons on the bottom. There's no charge here because the electrons are equal to the protons. If there was a charge, I'd write it over there also. Isotope name, this is just oxygen-17. It would be silly to write oxygen 8 because oxygen's always 8. We're trying to give somebody information and tell them that the mass number is 17 for this particular one. In this case, charge is 0. Now magnesium. Magnesium is over here. So magnesium is atomic number 12. There's 12 protons, so atomic number is 12. There's 13 neutrons. 12 plus 13 is 25. If I rewrite it as a nuclear symbol, I'm going to put 25 on top. I'm going to put 12 on the bottom, mass number over atomic number, Mg, and then I write Mg-25. Now the charge. I look at protons and electrons. They are not the same. So this is not an atom, this is an ion. And then I ask myself, what is there more of? There's more protons, so that's positive charge. How many more? 2 more. 12 versus 10, there's 2 more protons, so it's plus 2. So over here I write plus 2 also. All right, next one. I know there's 23 electrons. I know it's 26 for iron and 56 for the mass number, so I got lots of information here. Mass number's on top. The atomic number is on the bottom. That's equal to the number of protons, so I put that there. I'm given the element, so I know it's iron. The neutrons, I know if I take the protons and subtract it from the protons and the neutrons, I can figure out neutrons. So 56 minus 26 is 30. And then over here, it's Fe-56. I want to tell somebody the mass number and the charge. I got 26 protons and only 23 electrons. That means it's an ion. There's more positives. 26 is more than 23. How many more? 3 more. So plus 3 charge. So you should be able to fill out those tables in your sleep by now. All right. Let's figure out the chlorine business. Now, chlorine has 2 isotopes, chlorine 35 and chlorine 37. 35 is more abundant than 37. What I recommend you do is make a little number line for yourself. Put the percentages there. This is 75.77%. This is only 24.23%. Ask yourself, if you're a little kid doing averages, where would it be? It would be right there at 36. We're not little kids doing averages anymore. We're using the average atomic mass weighted average method. So we're going to shift this average closer to the one that's more abundant. So your average is not smack in the middle. It's going to be closer to this guy because this one's more abundant than that one. How do we mathematically do that? You multiply 35 times the percentage. Move your decimal 2 places. We're not putting 75.77% in, we're putting 0.75 in your calculator. And then you're going to multiply 37 times 0.2423, and you're going to get your subtotals. And when you average them out, I forgot to do this, so I have to run the numbers. Hold on one second. You get 26.5195, and over here you get 8.9651. Add them together, just add them, don't divide by anything. This is a different method. The only reason you divided before was because everything was equally important. And when you add them together, you get 35.5 or 35.48446. But we can round that to the tens place, 35.5. So our average is not smack in the middle. It's shifted closer to the one that's more abundant, and it's right about there, 35.5. When you're done and you come up with an answer, please use logic. Ask yourself, does it fall between my low value and my high value? If all your grades were between 35 and 37, you would wonder if you got a score on your report card of a 16. 16 doesn't fall between 35 and 37. So check to see if that number does fall between the two, and is it closer to the one that's more abundant. Now let me give you a heads up. You might have a multiple choice problem like this. If you have a multiple choice problem, you should use some common sense before you do the math. If you know that your low is 35 and your high is 37, and one of the choices is 34.2, or another choice is 38.9, or 36.0. These choices can all be ruled out because you can't have an average of 34 when your low is 35. It's got to be between these two, so it can't be that. And 38 is too high, so it can't be that. And 36 is smack in the middle, which would be fine if they were 50-50, but they're not, so it can't be that. So you know that your answer has to be over here somewhere because it's closer to the one that's more abundant. So it can't even be anything greater than 36. So you can use common sense and narrow it down. You might not even have to do the math, hint, hint.